Yes. So what I was saying was Lambda was one of the first services I learned. It was one of the most services that are close to my heart, and they showed me the real meaning of cloud and everything else. I think we're gonna do a small hands-on labs. We're gonna see the difference, how fast it is. Uh, like Lambda is so much faster than virtual machines, and we're gonna see that in our lab at the end of the lecture. Okay. So, of course, my dog and his stuff. So let me close that tab and let's start our lecture. So, of course, today we're gonna talk about Lambda, and this is the icon for it. So, what are we gonna talk about today? Of course, as always, we're gonna give a brief introduction. We're gonna talk about the key features and concepts. We're gonna see how it works, few execution models, use cases, on some pricing, and then at the end, we're going to give a brief hands-on lab. Of course, Lambda is kind of free. We're going to talk about the pricing, but we're going to see how. Okay, so introduction. Before we start, does anyone have any kind of idea what is Lambda? Is it a compute service? Is it a database service? Is it an AI service? So does anyone have any kind of idea what is Lambda? I'll give you a hint. It's the first word I have said. Of course, if it was me, I wouldn't remember because I was like, okay. So guys, it's a compute service. It's one of AWS compute services. So, and it is something that is called a serverless service. So if you can see here, I have a serverless tab. And if we open, oh, I should have opened it in a new tab. That's fine. I'll open it in a new tab. So there's this website that's called Serverless Land, and this is going to teach you everything about AWS Serverless. And who gives these lectures are my friend Eric. And as you can see here, that if we go down, we can see Lambda as one of the serverless services in AWS. So we talked about serverless. We talked about that you don't manage any kind of infrastructure. You just manage the business logic, the thing you need, and that's it. You don't manage any kind of configuration, any kind of infrastructure management, nothing, just the code. So this gives us the ability to call this service platform as a service, so PaaS, PaaS. This exact service, or Lambda, gives you the ability to run code without provisioning or managing service. So this is for code. And with Lambda, you can execute code in response to events, which are called triggers. And we're going to see that now. So let's think of Lambda as an alarm clock. Okay. So alarm, clock, maybe. Okay. So you know these things in movies, and when you wake up, these alarm clocks, when it hit like 6 a.m., 7 p.m., they trigger and they start making these awful noises to wake up on the morning. So let's think Lambda as the same thing. So on 7 p.m. or 7 a.m., sorry, so 7 a.m., this is gonna trigger and it's gonna keep on making these horrible noises. So this is Lambda. It's gonna work when something triggers it. So when a certain functionality or a certain event happen, this is gonna cause a trigger and it's gonna cause the function or the code to run. Okay. So a basic example we can think of that we can integrate S3 buckets. We're gonna talk about S3 bucket, but it's a place for storage. So S3. So we can say that every time that a user uploads a picture, so a picture create by Lambda, this is the Lambda function. So create a Lambda like a text called picture uploaded. Picture uploaded. So send this message every time a customer or a user upload a picture. It's gonna trigger a Lambda function to send this message either via email, whatever. So what advantage does this give us on normal virtual machine? First thing, it's much faster than virtual machines. Second, you don't have to keep it running all the time. So if you were having a virtual machine and you saw we lost multiple virtual machines, you have to keep it running like 24/7 because you don't know when you can have customer. Like if you uploaded this kind of code on a virtual machine, you have to keep it running 24/7. You're gonna pay for it, even if it's not in use. So that's a very bad idea to use virtual machines from my perspective. So this is more cost optimal solution to do so. So it just works anytime that the customer is uploading a picture. So I think, guys, this is a great idea. I don't know if you agree with me, but I think it is a very cost efficient idea. Okay. So we have talked about this. There's a few things that we can call as events. We have either Amazon S3 buckets, as we talked about in this picture. We can also have a database table like DynamoDB or any other kind of service. Maybe in the serverless lecture that is going to be soon, I'm going to teach you how to connect a Lambda function to an API gateway, and we're gonna see how you can shift between websites, and we're gonna do some cool stuff. Yeah, serverless is for cool guys, I guess. Okay, so we have a few key features. I've talked about them when I was explaining, but again, we talked about it as serverless. We've talked it's event driven, like uploading this photo. It's also scalable because you're not going to manage any kind of infrastructure. This is the main concept of serverless. So it's going to scale. It's going to add more Lambda functions or remove them based on demand. Also, AWS integrated services, so you can integrate it with any kind of service, and it's flexible. So yeah, kind of the best, one of the best services, I guess. Okay. So key concepts, we have a few concepts we're going to talk about. We talked about triggers. Now we're going to talk about the rest, I guess. Functions is the literal code. So I'm going to show you a code I have for Python, so sticky notes. You don't have to know Python. You literally can get it on ChatGPT, but I'm going to show you my code anyways. So I have this code. Let me just copy and paste it and upload it right here. So text. Oh, that did not work. So code. Will it like paste or something? I don't know. I'm gonna try copy. Okay, here it is. Great. So this is a Python code. This where you put it in the function area of the Lambda function. So this literally is a code. So you are gonna import the JSON module in Python, and then you're gonna do this function, and then you're gonna define this function. So if everything is okay, it's gonna print out the status code, and it's gonna give us the message hello world. But if it didn't, it's gonna like, I think, yeah, it's gonna log the output. It's gonna give us an output message. So this is gonna show us, wait, okay. So this is gonna show us, we're gonna use this code eventually on our hands-on lab. Okay. So runtime is when we run and test and deploy our function, and we're gonna see that right now. So we've talked about yesterday, we've talked about runtime, which is responsible for running our function code. We've talked about it in the container service. Also, Lambda uses containers, so that's good. Trigger, we talked about it. So if you remember, sir, trigger, we've talked about it. So it's like literally that annoying ass clock. This clock right here. So it's at 7 a.m. This time causes a trigger to this clock. So that's a trigger. It's an event. There's a lot of services that can cause events like API gateways, DynamoDB, and S3 buckets. So let's look at, okay. So concurrency is basically, it's a really cool idea. So let's imagine this, but like multiple users are sending like multiple images. So this is gonna cause it to concurrent. So these Lambda functions are gonna work I can't pronounce it. Sorry, guys. This is the words simultaneously. And it's gonna scale based on the number of triggers and the number of functions that are happening. So this is really good because it's not gonna give you any kind of downtime. It's gonna help you. It's gonna help you like serve your clients better in a more responsive way. So here you can see Lambda automatically scales your function concurrency in response to upcoming events. So it's based on the events, the triggers, and that's it. Execution role. Of course, this is very important. So when we're gonna work on our hands-on labs, you're gonna know that Lambda functions require IAM roles to give them access and permissions to other services and even for them to work. So Lambda functions do need a role in IAM, and we're gonna create one. So how does it works? It's kind of easy, really easy. You just upload your code, set a trigger, execute it, and then it's gonna automatically scale based on the triggers you have set. Okay, so supported languages. So we've talked about that. Okay, Lambda do support running code. So what kind of languages does it support? So actually, they support a lot of languages, but even more, like the primary ones are Node.js, Python, Ruby, Java, .NET. And if we like go to our console, we go to our Lambda, and then we can see when we try to create a Lambda function, we're gonna see like how many rules we can do that. So let's go and see here. You can see how many languages we have. We have Java, .NET, Python, Ruby, and Node.js. Where is Node? This is the latest supported, other supported, yeah. You can see Go, Rust, C++, and you can custom it, so based on what you want. Okay. So it supports multiple languages. That's great. There's this number 6, of course, we're gonna talk about execution model. So execution model is gonna talk in deep on how does AWS Lambda works. So AWS Lambda is it's not complicated, but it has a certain kind of procedure to work on. So the first procedure we're going to talk about, of course, an execution model, it's a way to describe, it's a way to manage and execute these functions. And it is very important to understand what does execution model mean so you can know what you're doing. So you would know what kind of functions do you need to use, what kind of things can you use it for, and that's it. So before we begin, I want to note that Lambda functions are best suited for workloads that can run under 15 minutes. So anything that is fast, like as I said here, like sending emails that the picture is uploaded, or anything that is less than 15 minutes, this is where AWS Lambda is best suited for. Anything about 15 minutes, like machine learning processes. This one time I was training a car to walk on a road. So literally a car. Oh, sorry, my screen just lagged. Okay, so we have a car. This is our car. It's a potato car, and I've teach it to walk around this line. You know this line. So actually, it took me like an hour to train it to a one like to make it go like once. It took me a full 1 hour to do so. So this is not suited for Lambda functions. You use other things. You can use virtual machines and stuff like this. So yeah. So anything that requires like AI, machine learning, stuff like above 50 minutes are not suitable for Lambda functions. Okay, so we have talked about event source triggers, which are, of course, the cycle begins at a trigger, as we said, the clock. So how Lambda functions, the first step, it needs a trigger. That's it. So the trigger can be from, as we said, S3 buckets, DynamoDB, API gateway, or any kind of custom triggers or events you want to use. So we start with the trigger. Then we are going to have something that's called an invocation. So if you know a little bit about programming, you're going to know about invocations, you're going to know about synchronous and asynchronous invocation, especially in JavaScript. I remember I was using synchronous and asynchronous callbacks. It's literally called async and function. I was using it when I was writing JavaScript. So it's the same, it's kind of the same. So synchronous is the caller has to wait for a response, and asynchronous, he doesn't have to wait. So let's draw this like really fast. So we have our user. I think it's in the elements part. Okay, so let's get our user that we use a lot. Here's our user. And let's get our, let's say computer, I guess, or server. So let's say server. Okay. And then we're gonna have our, like, maybe database server, or this is a nice server. I'm gonna use this. Okay. So synchronous is a client sends a request and then it waits, so waits. Then it's gonna send the response back. So this here, it does some calculations, like it does a few stuff, then it's gonna send the response back. But an asynchronous invocation, you get like a message, maybe, let's say, an asynchronous, if the request is sending the server a message, the server is gonna send them, okay, I got it, that's good. Okay, so let's read. So invocation, once it's triggered, AWS invokes the function to work by creating an instance of the function handler. And here's two types of invocations. We have synchronous and asynchronous. We've said that synchronous, the caller awaits for the function to process the event and then return a response. Asynchronous, no, the events run in the background and the caller does not have to wait for the function to complete. Okay, well, that's good. So this picture, actually, the one we have talked about where he sends pic to S3 buckets and then they send, like, these functions send an email that the photo is uploaded. This is asynchronous because literally you just get a trigger and it just sends an email. So that's really quick. Okay, so we have something that's called a container initialization. We've talked about containers yesterday, and Lambda uses containers to run their code. And this is what's called a cold start. So when it starts initializing a new container, this is what's called a cold start. We're going to talk about cold and warm start in like these slides right here. But I need you to understand that when a Lambda function is running a new container, this is called a cold start. It's going to take more time. It's going to cause more latency, but it's cheaper. So it involves initializing a runtime environment, setting up dependencies, and loading function code. We've talked about containers and how containers are used to bundle up like software runtime, software code, software dependencies, and libraries all in one container or one package. Okay. So handle execution is how the function is handled, how functions handle processes on the incoming event. So this is the main entry of the function code, and it contains the logic to process the event and generates a response. Okay. And then we have a response or callback. It's either once the handler completed, it returns a response, which is the synchronous invocation, or signals complication via callback or promise, which is asynchronous invocation. So again, if the handler sends a response after completing the execution, like as we said here, let's go to our server. So here he does some calculation, then he sends the response. So this is sync. And this is async, or asynchronous. Okay, so if if the handler completes the execution, then he sends the response, it's synchronous. Or if he, of course, very fast sends the callback or promise, it's asynchronous. Of course, guys, if you write JavaScript, you're gonna know this, or for me personally. Okay, so we're gonna talk about cold starts and warm starts. Maybe from hearing the concept of a cold start and a warm start, maybe you can understand that a cold start is like you what I imagine. I imagine someone is running, and then when he's running, he's very cold, so he's slow at the beginning. Then he gets faster and faster by more running. A warm start is someone who's already hot and he's running, so he doesn't need any time. Of course, as we said, a cold start in the previous slide, it occurs when a new container is initialized. It's also used to create it to handle an event. They can additional, of course, we've talked about because it's cold, it's gonna have more latency. It's gonna take more time to run the code, but it's cheaper in cost. Okay, so this cold starts cost less than warm starts. Warm starts when occur when an existing container is already there and it's reused, so it's much faster. And they skip the initialization process, reducing the latency significantly. But this is a little bit more expensive, let's say. Okay, so pricing of Lambda function, we have compute time, we have free tier. Of course, you're going to have, like if we open AWS Lambda, we're going to have, I think, the first 2 million invocation for free. So let me, here it is. So, oh yeah, I should have for pricing first. Okay, so here you can see that AWS Lambda on free tier, you can have also 1 million free requests per month or 3.6 million seconds of compute time per month. Then you're gonna start getting billed. Okay. Use cases. So we have either web application, data processing, IoT backends, because literally like IoT backends, if you clap at the light, it's gonna light on or off. So this is really fast. It's gonna take less than 50 minutes to do. It's gonna take less than like 3 seconds to do actually. And it doesn't need a virtual machine that's running all the time just because it's gonna wait for you to clap and then turn on or off the lights. So it makes sense. Data processing, maybe if you want to upload a photo and it's going to create a thumbnail or something like this. Automation, of course, because you don't manage any kind of infrastructure, it can be used to automate tasks, and it can be used to integrate with multiple services. Okay, so monitoring and logging. If you remember, we've talked about monitoring a lot. So anything that is related to monitoring, it's gonna be CloudWatch, the god of monitoring. Me personally, I like CloudWatch. I don't like the alarms though; they make me nervous. Okay, so CloudWatch logs, they capture the logs. We've talked about logs in Linux. So this is if anything happens, it's gonna store, or any kind of action that happened, it's gonna be stored in CloudWatch logs. Metrics, we've talked about them, I think, in the autoscaling group. A metric is a way to, like, it can be used for invocation count or error rates or any kind of anything. For EC2 instances, CloudWatch metric we used was CPU utilization. We've also seen that we have network in, network out, maybe memory utilization or CPU utilization. So you have a lot of, like, let's go and check it out actually. So let's go to CloudWatch. We're gonna go to CloudWatch, anything for monitoring, CloudWatch. So if we want to check any kind of metrics, here you can see that we have our logs that we talked about, metrics, and then alarms. So let's go at metrics and let's see the Lambda metrics. So we don't need here Lambda. Okay. So we have 17 Lambda. We have by resource, by function name across all functionality. So let's check by resource. We have throttles, test errors, duration, concurrent executions, and invocation. So you can see here we have a lot of something to use. Alarms is set up on alarm if we're having huge error rates or long execution times, like more than 15 minutes. Please send me a notification that this thing is taking more than 15 minutes. So change than using S3 bucket. Okay, thank you for watching. Thank you for finishing the theoretical part. Does anyone have any kind of question before we go to the hands-on labs? Why is this? Okay. So does anyone have again, any kind of questions. I think in the hands-on lab, it's gonna be more clear. So let me send you guys the code that we're gonna work on. Let me remove the word code because I'm gonna copy and paste it. So I'm gonna send you guys the code if anyone wants to do this with me. So here you go. Paste. Again, this is a Python code. Okay, so let's go to our Lambda, sorry. So let's go to our Lambda, and the first thing we said that at the beginning of our lecture, if we want to execute our Lambda function, we need a role. So here it is. We've talked about execution role. So anytime we need to use a Lambda function, we need a role. So first thing, we're going to create a role. So let's go to IAM and then create a role that we need. Of course, we've talked about roles in our first lecture about IAM. We've talked about that roles are used for services mostly and accounts. We also have like a lot of stuff. So we're going to use it for an AWS service, which is basically Lambda. So we're going to use Lambda. Then we're going to use Lambda basic execution role. So Lambda, I think this is it. Basic execution role. So let me open that and show you guys. Here it is, Lambda basic execution role. So this gives the abilities for Lambda to execute. That's great. So next. Unroll means, so let's gonna call it Lambda role test. One. Okay, that's enough. I'm joking. Okay. So create role. And then the role is created. So that's great. So we did the first part of our part is creating a role. Then we're gonna create the Lambda function and attach this role to this Lambda function. So let's do that. Create a function. And then we're gonna give it from scratch. You can use a container image or use a blueprint, but I'm gonna use it from scratch because I already have the code. And as we said, so let's call it, I need the name, guys. I need the name. So does anyone have, can sacrifice their name? If you want to sacrifice your name, please raise your hand because I need the name to use for my Lambda function. Okay, I'm gonna use Sam's name. I think I broke my charger. That's fine. Okay, thank you, Sam. I'm gonna use your name. Oh wait, no, I don't need that. I just need this. Okay, Sam Maya Lambda. Oh yeah, that's good. That's a good name. Okay, I already entered that. Let me just write it. Sam Maya Lambda. And we've talked about that we're using Python. I'm gonna use the older version just to be more safe, so 3.9. And that's it. There's nothing. Oh yeah, permissions. I have to give it the role we need. So use existing role. We can create a role with basic Lambda permissions, but we're gonna use that role. So it's Lambda role test one. I remember. Okay. So here we have created our first Lambda function, our most interesting thing in the world, and we have our code. This is a basic code that's gonna send hello from Lambda. So if we test that, it's gonna give us, so event name, so Sam, event one, let's see. So I think the log of this, so if we said test, where is it? I can't find it anymore. I should have write this one. So Sam test two, let's say. This is the thing that it gave us. So the response of this Lambda function was hello from Lambda and a status code of 200. Of course, for the code I have sent you, it's gonna give us like more details and it's gonna give us hello world. So more stuff. Sticky notes. I'm gonna go to code and remove my code and deploy it again. So let's get the code I have sent you guys. Let me remove this first. Okay. So here's the code. We're gonna import JSON module. We're gonna print the log. We're gonna print everything that we need. That's great. So because changes are not deployed, we're gonna deploy it. And then we're gonna go to the test board. Name it sound test 3. And then we're gonna test I did. Wait, I have changed the code. That's weird. Yeah, I have. No, wait, it's right. What's wrong with me? It says hello world. The first one said hello Lambda. I think I think I just got confused a little bit. I'm sorry, guys. But here you can see that the success code it says hello world. Like here, the code we have entered says hello world, as you can see here. I just got a little bit confused, guys. So as you can see, that Lambda is very easy to use. It's much faster than virtual machines. As you saw, like literally just pip test and that's it. You can like set a few triggers, a few stuff. I don't want it to be very advanced. I just want to like give like a brief introduction about Lambda and these kind of stuff. Okay, guys. So this was a very quick lecture and an enjoyable one. I really enjoyed today's lecture. But please, guys, before you go, I want to ask you something. So let me go to my Slack. Just give me a moment. And I need you guys, please, to give your honest feedback, whether it's good or bad. I said I take bad comments very, very seriously. Not in a bad way, not in a personal way. I like to improve myself. So guys, please submit your feedback. Of course, the club name is AWS Cloud Club in Jordan. And the event name is AWS Lambda. And today is 1st of August. So please, guys, before you go, please make sure to submit your honest feedback.